Hey everybody, in this video we're going to look at or analyze a function. Now we're going to look at this over an open interval, which means we're just going to look at a portion of it. We're going to look at through these two endpoints, whatever they may be. Of course this function could continue on in both directions, but we're only going to look at this little portion, this kind of, we're only interested in this space right here between these pink endpoints. So if this is on an open interval, that means that it goes up to those values. It doesn't include those, if we were to differentiate this thing, remember that f prime is the equation, the derivative of this is the equation for the slope of f of x. So whatever this function is on whatever interval we're looking at, whatever open interval, or maybe we look at the whole function even as it goes off to infinity, we have to remember that the derivative of this is the equation for the slope at any point on the function. Okay? So what we're going to be interested in as we analyze this is when our derivative equals 0. And what does it mean when our derivative equals 0? Well, that means our slope equals 0, and that means that we're going to have a horizontal line there. We're going to have a horizontal line or a horizontal tangent line on f of x at those points. Now there's a few places on here where we've got that, but we're going to look between a and b, so let's just do some labeling before we get to our points. So we've got a and b, those are our endpoints, and let's see, we've got a few spots where this thing is going to have a horizontal tangent line. So the first one is going to be right here, and let's just call that C1. So that's just some points in between A and B. And we've got another horizontal tangent line, or another place where we would have a horizontal tangent line is right here. We'll call that C2. Another one down here, and we'll call that C3, and we've got one more up at the top here, and we'll call C4. Now you may have noticed that all of these things are at the top or the bottom of a curve. These things are called extrema. Extrema, it's just a plural word or a plural term for minimum or maximum. So we're going to be looking at the extrema of this function. And specifically with those extrema, we're going to look at two types. One's called a relative or maybe a local extrema, depending on who you're speaking to, which textbook you're looking at. It's called a relative or local extrema. Now a relative and local extrema, that's where it's an extreme, either a minimum or maximum value with relation to the points around it, immediately around it. So that's why it's called local. So we're looking locally at that area, and we'll determine if they're minimums or maximums. Then we also have what's called absolute or global extrema. So global extrema is going to be when we have a maximum or a minimum for the whole function or the whole interval that we're looking at. All right, so let's take a look at some of these different points and see if we can identify what some of these things are. So first with A. A is out here by itself. If we look across the whole thing, the whole function, A is going to be the lowest point across the whole function on the interval of A to B. So this endpoint is going to be our absolute minimum, because it's the lowest point in that whole interval. Now what about C1? Well, C1 I'm going to hold on to for 1 second because that's a little unique, so let's move on to C2 next. Okay, so C2, if we look at it, when we come across from the left and we come across from the right, we can see that it's going up to a peak. And this peak is going to be our relative maximum, because it's the peak, it's the highest point within that area of the function. So it's the relative maximum. When we look at C3, well, we can see that that's going down into a valley, so that's going to be a relative minimum. Relative minimum, because it's looking at the bottom part of this. And if you look at where C3 is, that's going to be the lowest point in this area of the function. C4, I think you're probably seeing the pattern here. C4, as we go up, we've got a relative maximum. It's kind of at the peak there. But if we also look across the whole function, this is also the maximum point on the whole function, on the interval that we're looking at anyway. So this is both a relative and an absolute maximum. So a point can actually be, or a value can actually be, either a relative or an absolute or both, right? It can be depending on what you're looking at across your interval. All right, so now let's go back to C1. Well, what's happening at C1? Well, we start by kind of going up the curve, so it's kind of moving upwards, but then once we pass C1, it still continues to move upwards. So it's not that it's a maximum, or it's not that it's a minimum, it's just kind of a pause point. So this is neither a minimum or a maximum. But since it kind of pauses right there and then it continues to move up, this thing is kind of a special one. It's called an inflection point. Inflection. So we'll talk a little bit more about inflection points later on, but it's good to note that if you see that where you have a horizontal line, or where you have a horizontal line, or you have some kind of pause in your function, that is called an inflection point if the slope values don't change. So like here we're looking at positive slopes. So the positive slopes don't change, they stay positive around this inflection point. So that's what makes it that inflection point. Okay, so what are all these things? All of these, oh, I almost forgot about B. So B, if we look at that also, well, B is not, it's not a relative. We can't look at a relative point because we don't really know what's happening outside this interval. We only know what's happening coming from the left. So because it's neither, we don't know what's happening on both sides, we can't call it a relative. It's not the highest point or the lowest point across the whole function. So this one is also neither relative nor absolute. Okay, so all of these things are called critical points or critical values of f prime of x. Now what does it mean to be a critical value of f prime of x? These are where all of the x values equal 0 on the function. So if we were to, or on the derivative, sorry. So if we were to take the derivative and we were to solve for 0 at all of these points, we would get a 0 value for x, or we would find a value, excuse me, let me rephrase that. We would get a value for x that when we plugged it into the derivative function, it would be 0. Let me say that again. When we look at all of these points across this interval, each of these values, when plugged into the derivative function, it would give us a 0 value. So we would have the function, the derivative function equaling 0. So these are our critical values. And these are just looking at the x values. So what if I want to say what point is the absolute minimum? Well, the point is going to be on the function f of x. So if we're looking for the point, then we would take our a value, and that would be our x, and we would plug that into our original function f of x. So our point would be a plugged into f of x, which would then we would calculate out, and we'd get a y value, so we'd get a f of a. So that would be the point of the absolute minimum of at a. If we were looking at C1, well, if we wanted to know what point we have an inflection, we would have, well, we know that the x value is C1 and the y value is going to be f of C1. So plugging C1 into the function, not the derivative, the function. Because remember, if we plug it into the derivative, then we're going to get the value of 0. So f of C1 is going to give us the value of the function. And this continues on for all of them. So it kind of follows, obviously the same patterns for the relative maximums and minimums throughout. So this is just kind of an introduction to extrema values, relative and absolute, and we'll get into some more application of these in later videos.